Visual Rhythm and Beat. This work uses algorithms to explore new creative opportunities for remixing audio and video. Building on the analysis of musical rhythm in audio, we derive complementary analysis of visible motion in video, and show that by aligning visual rhythm with its musical counterpart, we can create and manipulate the appearance of dance. For example, there are about a dozen versions of this turtle video set to different music on YouTube. But if we look closely, the rhythm of our turtle friend's movement is actually pretty irregular. So no matter what music we play, his dance moves will eventually fall off beat. Our technique can fix this by aligning visual rhythm with music, which lets us automatically tune the motion that we see to whatever song we want.
'Cause baby, oh my, well it's unfair. Looking like that, make a gentleman stare. Feisty, show me how you work, love.
The second thing our technique can do is manipulate acceleration to change aspects of visual style. This is a bit easier to see than it is to explain. For example, here we have some archival footage of dancers from the 1950s performing at Charleston. These are pretty well-trained dancers, so we don't really have to fix their timing. Instead, what we're going to do is retarget their motion to a more modern dance song and amplify visible acceleration to create a visual style that's a better fit for the new music. So we've seen that we can manipulate timing and style, but all of the videos we've looked at so far at least resemble dance to begin with, which is not true of most video. So now let's take a look at the harder task of turning arbitrary non-dance video into dance video, a process we call densification. Our technique builds on the concept of visual beats, which are visible events that can be aligned with musical beats to create the appearance of dance. For example, this short segment of me speaking to the camera is not exactly musical. But each of my movements creates a different visual beat, and by traversing those beats, moving forward and backward in time with music, we can create dance. Now, a skilled video editor could probably create something like this by hand, but by understanding and automating the process, we can scale it to creative applications that would be impractical with traditional tools. For example, let's say we wanted to search through hours of C-SPAN footage to find moments of accidental dancing, where a politician's movement temporarily takes on the rhythm of music that no one can hear. With our algorithm, we can quickly search through large amounts of video to find these moments, and then dancify them to create a political dance party. I like to think of this work as a way to play creatively with very large amounts of data, which I think is a really exciting frontier for creative expression. So in this last example, we'll focus on balancing the automation we've built with a means of more expressive control. To do this, we'll start by searching for visual beats in cat videos from YouTube. Here are two of our inputs.
And another kitty snack?
Then we'll map visual beats to the events of a music controller, turning each of our videos into a visual instrument. Finally, we combine several of these visual instruments to create a musical video composition.
I make Meowny Moves, hey.
kitty.
Hey.